Hi, in this slide, we will talk about the introduction of population. We calculate population growth by looking at the change in population over time. The formula for population growth is below. P equal to P initial times Euler number the power of RT. P equal to total population after time T. P 0 equal to starting population, R equal to percentage rate of growth, T equal to time in hours or years, E equal to Euler number or exponent. Thank you.
This relationship was obtained from Isaac Newton's empirical observation of convective cooling of hot bodies in 1701, when he said that the rate of heat loss by a body is directly proportionate to the excess temperature of the body above of its surroundings. As a result, the temperature of a hot object cooling as a result of being exposed to a convective flow at T2 minus T1 will change as follows: dT1 over dt. If the energy lost from the hot body to the cooler fluid is supplied by a heat flow Q such that T1 remains constant, the steady-state form of Newton's law of cooling is as follows: T1 minus T2 equal alpha T1 over T2. This rate equation is commonly used to define the heat transfer coefficient alpha for all convective flow involving heating or cooling. It should be noted that alpha is temperature depending in some circumstances and is therefore not a linear function of the driving force. It should also be mentioned that the defining driving force varies from supply to system, but the complexity of any given process is usually reflected in the formulation of the expression for alpha, the value of which relies on the nature and feature of the flow system and range from 10 watt for natural convective between A and a vertical plate to 100,000 watt for dropwise convective or saturated water vapor at a vertical plate. The ultimate goal of tidy convective heat transfer is to determine that the value of the heat transfer coefficient as specified by Newton's law of cooling in terms of the physical parameters of the convection system.
Bismillahirrahmanirrahim. Now, I, Rushadi Nurkairin bin Rosaini Risham, number matrix AA212296, will talk about the problem statement for population question. From the question, it states that the black rhinos is an endangered species. Its global population has fallen from 65,000 in 1970 to 6,300 in 1993. By modeling the decline as exponential, answer the following question. A. Write an equation in the form of P equal to AB to the power of T, where P is the population of black rhinos, T represent the year after 1970. Round your values at A and B to 3 decimal places if necessary. B. According to the model, what was the black rhino population in 1980? C. According to the model, by how much did the black rhino population fall between 1980 and 1990? That's all for the population problem statement for population question.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Rafi Iskandar bin Syahrul Alimi with matrix number is AA21029. And today I'm going to present about the problem statement of the question 1, which is Newton's law. So in question 1's Newton's law, it is stated that in the last year of his study, Biden worked as an assistant in a small restaurant near to his college. As part of his job, Biden learned to cook a big pot of sambal at night, just before closing time so that there would be plenty of sambal to serve his customers on the next day. Biden also found out that while refrigeration was essential to preserve the sambal overnight, the sambal was also too hot to be put directly into the fridge when it was ready. The sambal had just boiled at 120 degrees and the fridge was not powerful enough to accommodate a big pot of sambal if it was any warmer than 30 degrees. Biden discovered that by cooling the pot in the sink full of cool water, kept running so that its temperature was roughly constant at 5 degrees, and stirring occasionally, he could bring the temperature of the sambal to 60 degrees in just 30 minutes. How long before closing time should the sambal be ready so that Biden could put it in the fridge and leave it on time?
Now we will talk about the filler table for the population question. The filler table consists of 4 things, which is the fact, ideas, learning issue, and resource needed. From the question, I found 2 facts, which is the first one, black rhino is an endangered species, and the second one, global population has fallen. The ideas that I come up from the question is the population of black rhinos from 1970 to 1993. The learning issue that we can come up is how to calculate the population of black rhinos throughout the year from 1970 to 1993. The resource needed for us to answer this question is first, reference through internet, second, formula of exponential growth and decay, third, calculator, fourth, reference through mathematical engineering books, and lastly, discussion with the group member. Now, let's solve the question A. Question A states that write an equation in the form P equal to AB to the power of T, where P is the population of black rhinos, while T is the year after 1970. Round your values of A and B to 3 decimal place if necessary. We can find the value of A from the question, which is the value of A is the value of population black rhinos in the year 1970. To find the value of P, we must use the information that we get. Just insert the value into the equation of P equal to AB to the power of T. P is the value of black rhinos from the year 1993. Meanwhile, the T is the value of the year from 1970 until 1993. Just find the value of B, and the value of B will be 0.865. That is the solution for question A. Now let's solve question B. Question B stated that according to the model, what was the black rhino population in 1980? We can find the value of A and B that we just solved from the question before. The value of A is 65,000 and the value of B is 0.865. To find the value of T, we just need to find the difference of year from 1980 to 1970. Now, we can find the value of population of black rhino in 1980. The population of black rhino in 1980 is 15,243. Now, let's solve question C. Question C states that according to the model, by how much did the black rhino population fall between 1980 and 1990? To find the population fall, we first need to find the population of black rhino from the year 1990. Just insert the value of A and B and insert the value of T where the value of T is the difference of year from 1990 to 1970. After inserting all the value, we found that the population of black rhino for the year 1990 is equal to 3,574. Now, to find the population fall, just find the difference of population from year 1980 and 1990. And the population fall between the 1980 and 1990 is equal to 11,669.
Based on the problem statement, we can categorize the outcome into 4 main components, which is facts, ideas, learning issues, and resource needed. Facts: Biden worked as an assistant in a small restaurant near to his college in his last year of studies. Second, Biden learned to cook a big pot of sambal at night so that there would be plenty of sambal to serve on the next day. For ideas, Biden could prepare the sambal early so that he can leave on time. Biden had to stir while cooling the pot in a sink full of cold water before putting it in the fridge. Biden has to cook the sambal at least 1 hour before leaving. Learning issues: how to calculate the time needed for the sambal to cool down. How to determine the time Biden should start preparing the sambal so that he could leave on time. Resources needed: reference to internet such as YouTube or Wikipedia or encyclopedia. Reference to mathematical engineering books. Discussion with group members and formula of the decays of growth and decay.
Assalamualaikum warahmatullahi wabarakatuh. Pada kali ini kita akan membincangkan mengenai solution, iaitu jalan kerja bagi menyelesaikan masalah yang diperoleh oleh Biden. Daripada apa yang kita peroleh daripada soalan yang kita dapati nilai-nilai yang boleh ditukarkan ke dalam persamaan. Kita mendapati suhu awal bagi sambal tersebut ialah 120 darjah Celsius. Suhu selepas 30 minit ialah 60 darjah Celsius dan suhu persekitaran ialah 5 darjah Celsius. Daripada maklumat tersebut, kita dapat menggantikan nilai ke dalam formula tersebut dan mencari nilai bagi K, iaitu constant. Setelah mengira, kita mendapati nilai K ialah 0.024587. Langkah yang seterusnya, kita dapat mencari masa yang diambil untuk mencapai suhu 30 darjah Celsius. Tetapi kita perlu menjadikan 60 darjah Celsius sebagai suhu awal bagi sambal tersebut, dan suhu persekitaran bagi sambal tersebut masih sama, iaitu 5 darjah Celsius. Setelah menggantikan nilai ke dalam formula tersebut, kami memperoleh masa yang diambil bagi sambal untuk mencapai 30 darjah Celsius daripada 60 darjah Celsius ialah 32.06 minit. Lalu kita harus menambah kedua-dua masa tersebut bagi mendapatkan masa yang perlu diambil untuk menyiapkan sambal sebelum kedai ditutup, iaitu 60.02 minit ataupun 1 jam 2.06 minit.
In conclusion to our topic, we can conclude that the two problems can be solved easily using formulas that are easily found. For the population problem, we can use the formula of P equals A multiplied by B to the power of T to find the number of rhinoceros after certain years. For the Newton's problem, we can use the formula of P equals Ts plus in bracket T naught minus Ts multiplied by exponent to the power of negative k t. Using the problems and information that we obtain from the problems, we can insert the information that we have obtained into the formula to solve the issue and the problem that we do. That is all from us. Thank you.